Hi folks, welcome in. A couple of things about me. I'm a Node.js person. I build and maintain Node.js. If you know me for that, that's great. If you don't know Node.js, if Node.js you think you should throw Node.js away and never existed in life, well, I'm sorry. Probably, this talk is not about Node, so maybe a little bit, but not that much. I am also sit on the board of the OpenJS Foundation and the board of the GraphQL Foundation, which is fun, make it fun, considering that MCP could have been a great application of GraphQL, and it didn't happen. So you all see, we can all think about why. Anyway. You're all using my software on NPM. I'm part of the black hole problem. This is usual problem. I don't know. 30 billion downloads, my software. I don't know. I'm one of those people. We are going to talk about the model context protocol, which is a lot of fun. Okay. I am going to say a lot of very known things about it. So sorry if this has been covered. You know them already. Okay. But it's important for the rest of the discussion. Okay, so the important part of MCP, okay, is that I think it gives your AI, your LLM, your models hands. Okay, they can change the word, touch the digital world. Now, a long time ago, I did a PhD on the Internet of Things, so which made you can create you can expose objects and things as APIs. So to some extent, doing AI MCPs allow AI to touch and change the real world, which I find really, really interesting as a thing. Also, I want to clarify what you will call the agentic loop, because I think is very important for everybody to keep this in mind when building those systems. Okay, and the fact that this loop is very slow. Okay, what is the key part of the event when you're building when you're interacting and building an MCP client or an app, okay, that uses this, you are spending, you have a full loop running at all the time, okay, where your app, you say, oh, I'm calling my LLM, and the LLM return me some tool usage, then with the tool usage, I'm going back to with the result, I'm going back to the LLM and keep this running over and over until it's finished. And might not be perfectly correct, but it's a high level enough description. Please let me know if I made something wrong. Anyway, so this is the kind of things you can expect, okay? And this loop is slow, okay? How many times you're sticking, oh, it's thinking, or fumbling, or whatever. Like I find that part of cloud code fantastic. Anyway. So one of the most important part of this is the fact that, when we are building those kind of system, the unit measure of execution time is now in seconds, okay? 2, 3, 4, 5, 6, 10, a second, a minute, I don't know. It takes forever for some extent, because you need to take the content, you need to run the tool, get the result, then send the result back to the LLM. It takes a few seconds for that to get back. It streams the token down. The user will wait, okay? Now, I find it very funny to some extent to see that the same user wants a response of a web page in less than 200 milliseconds, but it's totally okay in waiting for half a minute for a tool usage. Okay, well, anyway. So because of the cost of doing that work, okay, those tools needs to be coarse-grained, okay? A lot of people will say, oh, you see some of those projects and, oh, I'm just mapping my REST endpoint as MCP tools. Doesn't work, okay? You need to expose some more coarse-grained functionality because it will take, the cost of those invocation is high, so they need to make them count. Okay, and provide a lot of information in it. And you can all this system though is built. You have seen a lot of talks about server-sent event and streaming and those kind of things, and it's a critical part of the system because if something takes a long time, you want to be able to stream down, update, change things, and so on and so forth. And there is this sort of, bi-directional communication on MCP because it's a long-running system, okay? And you have long-running TCP sockets. Now, unfortunately, a huge amount of effort that was done in the last few years at the infrastructure side was moved to the serverless and Lambda response patterns, so request response, and not long-running processes. And now we are all a little bit in the industry is a little bit in the dark on how to get that going again. Okay, so MCP to do that adopted server-side events. Okay, now we have two kinds of MCP servers. Okay, one is the STDIO version of them. Okay, they run on your machine. It's okay. The other one is the one running on remotely on the internet. Okay, over a socket. Now these have a different kind of requirements, both of them. Okay, especially the one from an authorization and a security point of view. The challenges are completely different. Okay, they could not be set apart. Okay. More importantly, though, the local one is extremely stateful. Okay, it runs on my machine. You can't be more stateful than that. Okay, in fact, it's run by my client, like the MCP client or the model tool, the desktop tool, whatever, owns the process. So it's starting the process. So it's totally local. Okay, that's super stateful. Okay, by nature. However, we all know that building stateful systems on over the network and maintaining those connections open and maintaining that stateful open is hard. Okay. So the official TypeScript SDK is built in a stateful manner. Okay, it was born out of this STDIO pattern and is totally stateful. It maintains state all inside a bunch of maps inside the server implementation. What does this mean? It means that if I want to run it on a server remotely, now if that process dies, I lose that state. So it's not really, it's very hard to build a robust system out of that implementation. It's totally okay because the ecosystem is growing and so on. So how can we scale this? Well, we cannot really rely on all messages being delivered, right? Because according to Cloudflare, 20% of the TCP connections get dropped. So we cannot really rely on stateful servers, okay? Some of these is actually very hard because, they can be dropped for whatever reason. Oh, I'm walking around on my phone, connection is dropped. Okay, we want to be able to run MCP on the phone, right, at some point. So this goes for all sorts of problems, okay? A TCP connection, my server can crash and die. Or I want to implement a scalable system so that I have a horizontally scaled system, so the more traffic I spawn more servers, but then when I reduce the traffic, I need to reduce the servers. But if if one of them is stateful, I cannot do that. So, so we cannot, because of this, we need to, remote MCP server will be disconnected from clients and will lose messages. This is part of the game, okay? And, one option could be, oh, but I have sticky sessions. How many of you have deployed a sticky session solution? So what is a sticky session? A sticky session, you have your client and you have your logic in your proxy, in your reverse proxy. And that reverse proxy maintains a map of the clients and the service it connects to. So when you receive that client, it always sends the message to that service. If you have run one of those systems, you know that there are challenges in operating it. So my typical answer to that, don't do it. Okay, a few people agree with me. Hopefully, don't do that. Okay, before going back, let's talk a little bit about message delivering guarantees and how those works, because I think it's very important. I said I had a background in the Internet of Things a long time ago, so this is kind of bread and butter for the Internet of Things people. Essentially, when you're doing, when we are talking about messaging and distributed messaging, we need to talk about the kind of reliability or delivery guarantees we can do. So we have a system for, we can say a message as at most once guarantees, or essentially fire and forget. We can do at least once, which means, oh, you might receive it more than once, but at least you are receiving once, okay, or exactly once. And exactly once is like two people dancing tango and making, exchanging a lot of things. It's very complicated. So, which I'm not going to cover in this presentation because it's not really useful. So at most once quality of service means, okay, there's no retry, no nothing happens, we lose messages. Not really useful. What we want really is a system that provides at least once quality of service guarantees. What that it means that there is some form of fax being sent all the time to say, oh, I have received that message. I have received that message. However, unfortunately, MCP does not have that right now. So, but it has something, okay? It has something. It has server-sent event provide most of what we need, in fact, okay? A lot of you might not know that server-sent events have this last event ID header, okay? And there is a long, if you look at the spec, there is a long paragraph, very obscure, to be honest, about resumability of state, okay? And all of that. I don't know, somebody implemented this, so maybe it's probably resonating with some of you, okay? And basically that tells you, okay, you have that. So I have an ID now, okay? I can, the client can tell me to resume from a certain given point. It doesn't really is an hack, okay? So I can't really cancel the message that I'm sending. So I can just use it to keep accumulating the story forever. Likely there is expired in Redis, so we can just remove them from the story once they arrive, but okay. So let's do a little bit of experiment. So given all of that, I was a little bit in trouble when starting to implementing some remote MCP servers and says, I don't think using this standard TypeScript SDK will get me far. I want something a little bit more reliable. So how can we do? What can we do? Well, I'm a Node.js person, part of the team that maintain the thing. So I'm going to use Node.js. All of what I'm saying can be implemented in all the other patterns and runtimes, so doesn't matter much, but I'm using Node.js. I also created a web framework called Fastify also. So again, this is the tool that I know and the tool that I'm using, but everything is kind of generic for this presentation. So I created this library called Platformatic MCP that is available on NPM to do more or less what we have been discussing. It supports all the features of the latest specs, including elicitation, including resumability, including notifications, and so on and so forth. It has all the things. It also has bugs. So if you try it and you find bugs, please report them and fix them maybe. Anyway, how does it work? Okay, it's based on a very old school pattern of using Redis or val key. You take your Redis and val key and you put all the state in there, okay? What are we storing in that state? Okay, we are storing the client authentication, okay, all that flow, okay? We are storing the stream states, okay? We know if a client is connected, okay? Now, in that resumability dance, okay, there is each client gets its own unique ID that is returned by the server. That unique ID is a key critical information, so we can even count who is connected. Okay, pretty good. So we can have these two systems, we can have those two applications running, and we can horizontally scale the system. Okay. How does it work? How did we implement the last event ID with Redis? Okay, when you get a connect to SSE, okay, and it goes to as a get. Okay, I don't know if you have implemented this, but the SSE, so you interact, tools interact via post, but then if you want to have line notification from a server, it's a get, and it starts, and it's a separate off channel, and then you start, the server starts sending events, okay? And then when the client reconnects, it passes in a last event ID that it has seen, and so it can receive them back, okay? The current state is maintained in Redis in kind of a list type of thing, so that you can say, okay, this ID, this ID, this ID, for each one of the client sessions. We also support the support for the auth 2.1 flow that it does, the infamous dynamic client registration. How many of you have tried to implement that? Okay, the guys, some people have been, and I see your face, okay? I see you, okay? That was something, okay? Anyway, it does the full complete dance of DCR, okay? I just wanted to note that it's actually very complex, okay? And in fact, I had to split it into multiple slides, okay? It's the most hardest part of this thing is what can you do when you start in this journey and then you discover that your authorization server does not support dynamic client registration, and then you essentially said, oh, hopefully there was a nice session before from Paul. Hopefully this is going to be addressed and we get a better implemented version of this in the future. Finger crossed, because this is very hard. The hardest bit is, you can see here, so the hardest bit is this dynamic client registration thingy, that it happens between the client and the authorization server that is not even passing through your MCP. And that is extremely hard because it creates an infinite list of clients on the authorization server, and most authorization server blocks you from doing that. So, and then because with a DCR, you have essentially one client, one user, and most identity providers, authorization servers, and so on, do not want that, okay? So it doesn't seem like the best tool for the job, at least to me. But it's there. Hopefully we're getting a better spec out of it, okay? It's a very, very long dance between the two systems. Okay, so more experiments. The demo gods, okay? I also have a recording, so I'll try the demo gods, and then we'll see, okay? I'm going to do demonstration of this auth dance flow so that you can have some fun, okay? So here we have my auth 2 server, okay? You can see we got some env files, but these just add a couple of interesting tools that just get the user details. Okay, so there's nothing but checking the details, perfect. So that's very straightforward, and then we just return the things. Okay. By the way, I mostly generated this with Claude, so whatever. You probably are familiar with the quality. So anyway, we can run this thing. Okay. Then I can go and do Claude MCP delete test MCP because I added it before. Oh, no, remove maybe. Yep, okay. And I'm going to do add. Oh, yep. Yep, you need to specify the transport because whatever. Okay, now it's running. Now we start Cloud Code. Okay, and we can check the MCP status. Okay, oh, maintains the state, but let me re-authenticate so you see the flow. What happens when you open it up? You go to redirected without 0. Okay, this is what I'm using, and you can log in, and then it's in, and then you can add get user details, for example, and you can connect to it, and so on and so forth. All the state is, as I said, is stored in the session and things. And you see it does it returns, and it does all the things that you would expect it to do. So the demo gods were with me. I only wanted to, if you want to try this kind of thing at home, okay, you can go. I want you to show how the most critical thing that you need to do is this bash script that you need to run. Okay, not that it has a while loop. Okay. This enables you to implement a DCR in Auth0, otherwise it's not going to work. Okay, so if you have tried that, if you are connected to Auth0 or Okta, please fix this for us, because this is was not easy. Like, you need to essentially configure this domain connection thingy in there. Otherwise, it didn't work. Don't know why, maybe it's fixed now. So this was 3 weeks ago, so who knows? There was no button in the UI. You needed to do it only via API. Okay, fine, I'm good. And 3 minutes. Here it is. I think I covered all the topics. So this was the video that I've just done. So I'm just, I was prepared to not having internet, okay? I wanted to say a couple of things about us, Platformatic. We build enterprise Node.js systems, okay? We help companies running Node.js at scale. We also wrote a nice little book called The Definitive Guide of Node.js in the Enterprise. It's free, you can pay with your email. So if you're running Node.js at scale or on-prem, we typically work with banks a lot. We are very happy to talk, bank e-commerces and things like that, okay? And yeah, thank you very much. If you have any questions, Matteo at Platformatic.dev.